we're going to use our rules for parallel lines to solve for our variables depending on the position of our angles. So here I see that we have two sets of x's, and our theorems, one of them tells us that if our lines are parallel, then same side interior angles are going to be supplementary. So these two should combine to give me 180 degrees. So 5x plus 5 plus 11x plus 15 is equal to 180. I end up with 16x plus 20 is equal to 180. 16x is equal to 160, and x is equal to 10. When I plug x back in, which we will need to do, this will be 50 plus 5 is 55, and 110 plus 15 will give us 125 for this angle, and just to double check, those do add to give me 180. I also know that all vertical angles are congruent, so the measure of z will also be 125 degrees. And I know that these two here are a linear pair and add to 180 degrees, so y will also have a value of 125. So there are the other two. Okay, here I've got another set of parallel lines. I know that if my lines are parallel, corresponding angles are congruent. So 2y is going to be equal to 80. Divide by 2, y is equal to 40. And over here, I have same side interior angles, which will combine to give me 180. Because if lines are parallel, then same side interior angles are supplementary. So 120 plus 4x is equal to 180, and 4x is going to be equal to 60, so x is equal to 15. All right, I have some more sets of parallel lines here. They're a little bit harder to see. I have those two there. I know that if lines parallel, corresponding angles are congruent. So x would have a value of 70. I know that vertical angles are always congruent, so this would have a measure of 50. And if we do 180 minus 70 minus 50, because I have a straight angle for the 70, 50, and y, so 180 minus 70 minus 50 will give me 60 degrees for y. And the last one, I have different sets of parallel lines here. I know that I have this set here, and I also have this set of parallel lines here. So if we focus on the green lines first, I know that alternate interior angles are congruent. So 42 is going to be equal to 3x. So x is going to be equal to 14. And I know that same side interior angles are supplementary. So if this one is 90, then this down here must also be 90. I've got 42 of that. So if I do, let's see, 90 minus 42 will give me 48 degrees. So 6y minus 6 is equal to 48. 6y is going to be equal to 54. So y is equal to 9. And for our proofs, we are given that BA and FE are parallel to each other. And also that BD and FG are parallel to each other. And we want to prove that angle ABC, so this one here, is supplementary to angle CFG, this one here. Now there are a few different ways that we can connect these. I'm going to actually number my angles so that it's a little bit easier to read in the proof. So I'm going to make this 1, 2, 3, and 4. And you can use multiple sets of these angles, but what we need to do is we need to create a bridge from angle 1 to get me down to angle 4. So one thing that I can see is that 1 and 3 are corresponding, and 3 and 4 are same side interior. You could also say that 1 and 2 are same side interior, and 2 and 4 are alternate interior. I'm actually going to use 1, 3, and 4 and start out with that. So we have our given statement that BA is parallel to ray FE and BD is parallel to ray FG. I'm going to go ahead and put both of those, and that is given. All right, so once we've got this statement, I can move down to the next set. All right, here is step 1 and step 1. Step 2, I'm going to go ahead and use angles 1 and 3. You can name them ABC and FCD if you want to. But you can also number them. So angle 1 is congruent to angle 3 because if parallel, corresponding angles are congruent. For step 3, I'm going to use 3 and 4. Angle 3 is supplementary to angle 4. Because if my lines are parallel, same side interior angles are supplementary. So here's where we're going to use that congruent supplements theorem. Step number 4. Angle 1 is supplementary to angle 4. That is our congruent supplements theorem. Remember that you can math this out. You would have to say that 1 and 3 are congruent, and then swap that to be measure of 1 is equal to the measure of 3. Instead of using the word supplementary, you would adjust that to be the measure of 3 plus the measure of 4 is equal to 180. You'd have to do some substitution. If you can remember that congruent supplements theorem, it's going to make things a whole lot easier. All right, we are given that the measure of angle 1 is 90 and that A is parallel to B. So let's look here. If we kind of follow our given statements, I notice a little bit further down. Let's see, we've got 2 givens. Angle 1, angle 4 is what we're going to have in step 2. So I'm going to list my parallel lines first. A is parallel to B. And then 1 and 4 are corresponding, which is why I want to go ahead and put that one there. If parallel, corresponding angles are congruent. The measure of 1 plus the measure of 4, we're just changing how it appears. So this is going to be our definition of congruence. And now I'm going to go ahead and put in that second part of the given. the measure of angle 1 is equal to 90. Now, notice the difference in 3, 4, and 5. What we're doing is we are swapping out the measure of angle 1 for the measure of angle 4. That could be, since we're replacing an entire side, that could be the transitive property of equality. It could also be substitution. Either one of those will work in that case. The measure of 2 plus the measure of 3 plus the measure of 4 is equal to 180. I know that there are 3 angles there, but they are making a linear pair. And the measure of 2 plus the measure of 3 plus 90. So what we've done here is we have swapped out the measure of angle 4 for 90. Sorry about that. So that will be our, since we're replacing one piece, this would be a great case where you'd use substitution. Our subtraction property. The only thing we have here to subtract are our numbers. So I'm going to leave the measure of angle 2 plus the measure of angle 3, subtract the 90. And 2 and 3 are complementary. That's going to be our definition of complementary angles. And last one, the measure of angle 5 plus the measure of angle 3 is 180. And I want to prove that line A is parallel to line B. So if we are proving line A parallel to line B, then nowhere can I have an if parallel then statement. We can't do it. So since this gives it to us in the math form, we'll go ahead and work it this way, and then I'll show you how to work it with congruent supplements theorem. So we're going to go ahead and start out with the measure of angle 5. And our given measure of angle 3 is equal to 180. And we need some sort of a bridge to get us a connection between 3 and 5. Now, if we can't use if parallel, then our keys here are our linear pairs or our vertical angles. So let's run with that. I'm going to use, in this case, 7. There are multiple ways and multiple sets that you could grab, but I'm going to go ahead and start out with that. The measure of angle 3 plus the measure of angle 7 is equal to 180, and that is because they are a linear pair. So now, if both of those are equal to 180, then what that tells me is that I can set them equal to each other. The measure of angle 5 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 7. And you could use transitive property of equality. You could also use substitution. And now what we want to say is that we have the 3's that are the same. So we're going to add in that reflexive property. We're saying, hey, the measure of this 3 is the measure of the other 3. These are the same angle. So this is our reflexive property of equality. And because those are the same, we can now subtract them out. So the measure of angle 5 is equal to the measure of angle 7. Subtraction. And I know that 5 and 7 are corresponding, but our theorems run in congruence. So I'm going to list that next. Angle 5 is congruent to angle 7. And that will be our definition of congruent angles. And because 5 and 7 are congruent and they are also corresponding angles, then I know that my lines are parallel. So A is parallel to B because if corresponding angles are congruent, then my lines are parallel. Now, just to show you a different method here with the congruent supplements theorem, and I'm going to go ahead and just use a different angle. Maybe this time we're going to use angle 2. So we're going to start it out exactly the same. Measure of angle 5 plus the measure of angle 3 is equal to 180. But we're going to change the wording. So angle 5 is supplementary to angle 3. That's our definition of supplementary angles. And now if I want to bring in 2, I know that 2 and 5 are vertical, so they are congruent. Angle 5 is congruent to angle 2 because vertical angles are congruent. And now what I know is that if 5 is supplementary to 3 and 5 and 2 have the same measure, I know that angle 2 would be supplementary to angle 3, and that would be our congruent supplements theorem. And if 2 and 3 are supplementary and they are a same side interior pair, then I know that my lines are parallel. So A is parallel to B because if same side interior angles are supplementary, then lines are parallel. So we've got 1, 2, 3, 4, 5 steps here. You could also use angle 4 and say that 5 and 4 are congruent supplements, and if alternate exterior angles are congruent, then lines parallel. You could use angle 1 and say that 1 and 5 are supplementary, so 1 and 3 are congruent and they are corresponding, therefore your lines are parallel. There are lots of different options here that you can use.